So I'm just going to give a presentation today on the aquatic connectivity study that we did on Tuscarora and Mill Creek's watersheds. For those of you on the call that don't know me, I'm Zach Norris. I'm the project manager at Cacapen Institute. And before I get started, I just wanted to mention some of the participating agencies and organizations, Downstream Strategies, the North Atlantic Aquatic Connectivity Collaborative, the U.S. Fish and Wildlife Service, West Virginia DEP, the Chesapeake Bay Program, and the CB Trust, Chesapeake Bay Trust. And before I get into it deep here, I want to go over a few definitions so we all are on the same page. Passability is a measure of the extent that a crossing allows the movement of aquatic animals. A higher score indicates more ability for crossings. A crossing site are locations where automotive or railroad traffic crossed over or fords a stream. Structures are the man-made devices that allow for a stream crossing. Structures include rock and concrete fords, bridges, culverts, or a combination. Culverts are the pipe-like structures that pass water through the crossing site itself. Culverts are constructed of corrugated steel, concrete. They can be round, oval, arched, and open bottom. Examples would be every stream crossing must have a structure. A stream crossing can include multiple structures. For example, a bridge with a culvert next to it, or multiple culverts in a row. The study areas, as mentioned, were Tuscarora and Mill Creek of Opequon. These are in Berkeley County of West Virginia. Both of these are on the 303D list as impaired for biological criteria and fecal coliform bacteria, and have total maximum daily load studies and watershed-based plans in place to address these impairments. Tuscarora drains approximately 26 square miles and is 11.7 miles long. Karst topography results in dry sections. We found 2 dams bar passage of aquatic organisms. Mill Creek drains approximately 29.8 square miles, the main stem being 14.5 miles long. 2 dams in this watershed create severe barriers for aquatic passage. Before I get into the results, I wanted everyone to see the field data sheets we utilized. These were developed by NAACC, and they're pretty extensive. The data form on the left, you can see for each crossing, we fill out crossing data, which includes lat long, things like the constriction of the stream, the crossing condition itself, the alignment of the stream to the crossing, whether or not there's a tailwater scour pool, road fill height, which directly correlates with the cost to replace a crossing. And then for each structure, we do a multitude of measurements on the inlet, outlet, and going to the second picture here, you can see the structure shapes and what we measure in terms of dimension for each structure. Round culvert, pipe, arch, elliptical, open bottom, arch, bridge, culvert, box culvert, and there's 3 different kinds of bridges: bridge with slopes, bridge with abutment, and bridge with abutment and side slopes. Additional conditions that we check for at each site when surveying is the substrate through the structure, if there's any internal structures, physical barriers, and the water depth and speed compared to the stream channel itself. The results. Initially, when we pulled the data, the GIS data off NAACC's website, we found 166 stream crossings. Of those 166, again, that pre-survey helped out. We only actually found 142 of the stream crossings. We were able to survey 109 stream crossings. Within those 109 stream crossings, we found 151 structures, 81 being single structures, 19 being double structures, 4 being triple structures, and 5 quadruple structures. So after we go out in the field, do the survey, fill out the data sheet, we go back on the NAACC website, input all the data, algorithm, that uses the data to determine what kind of barrier it is off of an aquatic passability score. And you can see all the possibilities here: no barrier, insignificant, minor, moderate, significant, severe, or no score. And you can see out of the 109 surveys that we did, 32 had no barrier and 42 were insignificant. I think this is a big takeaway. Majority of the sites that we surveyed had either an insignificant or no barrier. Another takeaway is that 8 of the sites, 8%, were severe. These would be locations to look at if we ever find funding to replace. You'll also note that 2 of the sites had no score. What that means is an example of no score would be a site that we were able to survey the inlet but not the outlet. So there wasn't enough data to utilize the algorithm to come up with an aquatic passability score. So starting with the best case scenario in the top right picture here, this is an example of a no barrier structure. This would be an APS score of 0.99 or greater. As you can see, there's substrate completely through. The typical low flow stream channel is much narrower than the crossing itself. You can see bank full within this picture. This is an example of no barrier. Going below that, an example of insignificant. Again, you can see substrate going all the way through. It's at stream grade. The stream channel itself is just a little closer to the width of the structure itself. And now to go on to some other examples. Starting in the top left, this would be an example of minor. This is one of the triple structures that we surveyed. You can see that this is a picture of the outlet, and you can see that there's an outlet drop to stream grade at the center culvert and somewhat of one on the left culvert. The box culvert on the right, although the picture doesn't really show it, is at stream grade and there is water there. So that's a minor barrier. Moving to the right, a moderate. This is a double culvert and both have an outlet drop to stream grade. You can't see any substrate in either one of the culverts. You can really only see the left one in the picture. So this is an example of moderate. Bottom left, we have an example of significant. This is a ford on Mill Creek that we surveyed, and you can see majority of the structure has an outlet drop to stream grade, which makes passability quite hard for most fish species. Also, the picture doesn't really show, but there was no substrate on the ford whatsoever, and the water depth on the ford was much less than 0.3 feet. Moving to the right, this is a great example of a severe barrier. This is the big ford on Mill Creek, and that outlet drop that we're seeing is 5.0 feet. So that doesn't really need much explaining. That's a significant barrier to aquatic passage. I wanted to give everybody a map view of what this looks like, all 109 surveys we did. So we'll look at a map of Tuscarora, and then we'll look at a map of Mill Creek. First, with the map of Tuscarora, you can see, I think, a great takeaway. Dark green means no barrier, light green means insignificant barrier. A nice takeaway of this is that we're seeing a lot of green. So a lot of our culverts within Tuscarora Creek watershed are in good conditions in terms of aquatic passability. One thing to note, you can see DS site number 1 in center screen. That's a severe barrier. So it only takes one severe barrier to bar passage to huge sections of a stream. So right dead center almost in Tuscarora Creek, excuse me, we have a severe barrier. So passage above is limited to above, passage below is limited to below. So that's something to note. DS sites mean downstream strategy sites. After we completed all of our surveys, downstream strategies took some of the severe barrier sites and made recommendations for replacements. And I'll So now let's look at Mill Creek. Mill Creek is about the same thing. I think a positive takeaway for West Virginia in this watershed is, again, we're seeing a lot of no barrier and insignificant barriers along Mill Creek, Torreytown Run, and Sylvan Run. Multiple, few severe barriers within the main stem of Mill Creek, and multiple moderate, significant, and severe barriers in the headwaters. But all in all, we're still seeing a lot of green, which I think is a positive takeaway from this study. Surveys, and we did find some interesting stuff. And I wanted to point out some. In Mill Creek headwaters, the culvert inlet, in this case, collapsed. The left picture, this picture is taken looking directly into the pipe. You can't see light at the end of the culvert. It's completely collapsed on the inside. It's rolled at the inlet that you can see. And it's perched also. So there is stream actually running through those rocks underneath the culvert. This was a pretty interesting find. Another interesting find on Mill Creek was a private land culvert we found in a field. Again, the stream's really running underneath this whole system. It's not running through these tires. It's just interesting that logs were used on the right side of the head wall, some rocks on the left side of the head wall, tires for the culvert itself with plywood and concrete there. This is just a poor example of a crossing. And then I also provided a picture of one of the CSX bridges on Mill Creek. In all cases, all the CSX sites were really good crossings for passability. I think they all scored very high, very wide, very robust structures. Just a few interesting finds I wanted to show. This was a long process for us, and we learned quite a few things, and hopefully some of these lessons can be utilized by people that do this kind of work in the future. The informal pre-survey of the existence and condition of stream crossings from the downloaded NAACC data will rapidly eliminate dubious data. We could not find 12% of total crossings right off the get-go. This saved us significant time when going out to do field work from looking for crossings. Pre-survey also allows for participation of untrained participants, volunteers, or local watershed managers. We also found that sending an introductory letter to all property owners near public crossings to introduce CI and NAACC proved valuable. There were many instances when we were out doing surveys in the field that property owners came out, talked to us. In a few instances, we were able to get permission to access private culverts. I think people just appreciated knowing that we were coming out prior to us showing up. Another thing to mention, moving forward, I was recently elevated to an L2 coordinator for the NAACC, which at this point allows me to facilitate trainings for NAACC. So the idea of doing a training for watershed groups or interested parties to get more of this work done in West Virginia is actually a viable option at this point. And then I'll end it here with just a picture. Two weeks ago, I was invited down, and I went down to Southern Virginia. Was invited down by the U.S. Fish and Wildlife Service to help train Virginia's inland fisheries biologists. And this is just two pictures from our training last week. A great group of people, and we actually had good weather, so it was a nice day out there. Thanks everyone for listening to me. I'm happy to answer any questions anybody has or comments.